presenter in this session. Okay, so today I want to talk to you about what research in recommender system gets wrong. So before I begin, so this is a polemic, right? So this is my personal take on what is wrong with recommender systems. So, don't take it personally. I take it personally, and this is what I'm going to talk to you about. And the reason why I want to talk to you about is because there is this agreement, seems to be, among the industry professionals that you should be reading academic computer science papers. It's not my invention. This is from Stack Overflow. And why should you be doing it? Okay, so in order to be cutting edge, you should be reading academic papers. That's what you should be doing. Great. However, when I speak to my colleagues from the industry and my ex-students, what often happens is they do read academic papers, but very often they just take it for granted, like God-given almost from us to the industry. And what I want to draw attention to here is that maybe you should take it with a pinch of salt. Just think about it a bit more. And so, as I said, this is my personal take, my little bugbears that annoy me in recommender systems. So these are the 4 issues that I want to complain about during this talk. Okay, so first, unoptimized baselines. So this is like a graphic of a recommender system. So in the blue box, we have a recommendation model that was built based on the interaction history that we collected from our users, which then is fed into the recommendation system to create a list of recommendations. That's great. So now we built our new beautiful model. And now we have to decide whether this model is good. Right, so in order to do it, you usually compare it against the baseline. So far, so good. So in the industry, the baseline would often be a system that you're currently using, or maybe some other system. In the academia, the baseline may be another algorithm, another model that was published in other papers. And yeah, that's great, but I want to draw attention to actually quite influential paper that was published at Rex's 2019. Where what the authors wanted to do, they wanted to, the paper was about the most important or the most published deep neural network recommenders that were published at the top venues like Rex's, CIR, dub. And they said, okay, so can we actually reproduce these models and get the same performance as described in the papers? So what they discovered is only 7 out of 18 models described in these papers were actually reproducible. And that's not it. So on top of it, what the authors of this paper did, they decided to use different baselines. So the authors of the original 18 papers, what they did, they just compared the system, or the models they created against other neural network models. So what the authors of this paper did, they compared it against existing recommender system algorithms, some of them very old and very basic, like user KNN, item KNN, very basic. And what they discovered is that if you optimize the baseline, even a very simple baseline, all of them actually outperform this fancy deep neural network models that were published so far. Okay, so this is what's the message I want to give to you. So that, I want to give to you the message is, if you read an academic paper that tells you that this new fancy model is just the best ever, please read it carefully and see what baseline they selected and whether this baseline actually makes sense, or whether it was just selected to sell the paper. So very often, these are kind of the coded message that was sometimes used in academic papers, which is like potential problems. We shouldn't be just telling openly that something doesn't make sense or is bad. Just like a phrase like potential problems is a big indication that maybe you should take it with a massive pinch of salt. Okay, so this is a message for you. So when you see this face, think about it and say, okay. Next, data leakage. Okay, so we looked at the model building. Now we looked at the interaction history. Okay, so a lot of you have knowledge or some background in machine learning, and what happens is machine learning, you take the data and you split it into 3 parts normally. So the majority of it goes into training the model. then there's a small part for testing it, and there's a validation set, a model selection set. And, in principle, this is fine because, in machine learning, all the data points are considered to be the same, so you can just pick any of them as a testing point or as a training point, shouldn't matter. However, if you look at the recommender system, from the perspective of the user, it does not always make sense, right? Because the user buys things in a specific order, he watches movies in a specific order, buys books in a specific order. So what often happens is you take a testing point that is actually, in the past, using data points for training or model selection. They are in the future. From the perspective of this data point, were never seen by the user yet, right? So this is called data leakage, and it's like you try to look into the future. Obviously, doesn't matter if you test the system online, but if you want to test it in simulation offline, it's a massive problem. And so what people in recommender system do in sequential recommendation, they just say, okay, so what we're going to do, we're going to use the very last point for testing and the last one for training, for validation, and the rest for training. Which is, fine again if you have one user. When you have data from a collection of users, then you still have the data leakage because, you borrow knowledge from the previous users. So we looked at this problem. 2 weeks ago, we actually published a paper at Rexis about it. We presented at Rexis, looking at data leakage. And our question was like, well, everyone knows there's data leakage, so maybe it actually doesn't matter. Like, it's there, but if it doesn't affect the performance of the system, maybe it doesn't matter. So what we did a lot of simulations. Sorry about this. And what we discovered is if we remove this phenomenon of data leakage from the training set, the performance of all the algorithms that we tested drops by between 21 to 73%. So there's a massive impact of data leakage on training on the models, right? And then we actually thought, like, we spent all this time, on simulations. We could have just looked at the data. So this is the data plotted. So there's this timeline of the test point that we took and the NDCG. So you can see that, the older the test point is, the better it performs, right? So it already shows there's a problem with data leakage already. And then we thought, okay, so if a system on its own just, it's affected by data leakage, but does it affect the overall ranking of the system itself? And here, the differences can be massive as well. So sometimes the worst performing model with data leakage becomes the best once you remove the data leakage problem. So, we here see a lot of problems. So what I want to draw attention to again is when you see studies, especially related to sequential recommendation, just look very carefully how the data was selected for training and testing, because be very, very cautious about it. Think about it. Now, the third point, made-up metrics. Okay, so we looked at the interaction history, the model. Now let's look at how we evaluate the recommendation itself. So normally what happens in recommendation systems, we borrow a lot of metrics from other fields, most likely from information retrieval, so NDCG and MAP. However, sometimes you want to test something different that hasn't been tested, let's say, in IR. So one of these things that recommender systems are interested in is serendipity. So you want to say whether the item that you recommended to the users is serendipitous. And, how do you do it? There's no specific metric. So, the recommendation system community came up with a lot of ways to describe serendipity. So the most common way to describe it is by using relevance, novelty, and unexpectedness. However, most of this, how do we find out that an item is relevant? What we learn about it from our previous interaction data, not from the users who just tell us it was relevant or not. So what we said, okay, so all this definition of serendipity, the Rex's definition of serendipity, is based on previous interaction data. Why don't we just ask the users whether they agree with this definition? So what we did, we conducted a big user study in collaboration with Estonian startup who recommends news recommendation articles. And what we did, as the items were recommended to the users, we asked them 3 questions. We said, is this item relevant? Is this item novel? Is this item unexpected? And, if we were to follow the established definition of serendipity that is used by the recommender system community, these are these items that should be serendipitous, right? But on top of it, after all these 3 questions, we also asked the users, do you think that this item is serendipitous as well? And here, what we find out, the majority of items that the users consider to be serendipitous are actually not captured by the definition used by the Rexus community. Okay, so when we actually looked at the overall performance, using this Rexus definition, what's relevance, novelty, and unexpectedness, it gives us the highest precision, although it's not massively higher than the rest of the definitions, but the recall is very low. It's like the lowest. It's much, much lower compared to if you just use relevance. And this is very important for recommender system because effectively you're not retrieving the relevant information. Okay, and again, here I would encourage you to pay more attention if you read papers related to serendipity in general, or any evaluation that kind of involves subjective opinions of users. Okay, here we go. So the last item is don't ask anyone. Okay, so what is it? It's kind of a bit similar to what I've discussed before. So here I'm going to talk about the dotted line which is the interaction paradigm. So what happens, we have different interaction paradigms in recommender systems. So a lot of it is just, recommendation based on items that the user saw before. So if you read books, it will be recommended books based on the books that you've seen before. But there's a lot of interest in the Rexus community, both industry and academia, in what's called the cross-domain recommendation. So, it's very, so you want to recommend items to users based on other areas. So here, for example, you might have users to whom we want to recommend books, to recommend movies, but we only have data from them from reading books. It could be because we have new categories added to our recommender system catalog, so we have to deal with this cold start problem. So what we do, we try to recommend books, movies based on the books that the user has read, for example. And this is fine, and there's been a lot of research into it, but actually, I don't think anyone has ever asked people whether they like this type of recommendation, whether they trust it. And it was a big surprise to us, as we're doing the literature review for a paper that we published last year at SIGIR, that we were the first group to actually ask people what they think about cross-domain recommendation, actual users, not just based on simulations. So, we did a lot of experiments here in user studies, but I just want to look at a small aspect of it, which is effectively cross-domain recommendation, what people thought about it. And what we found out is people actually don't trust very much cross-domain recommendation, and they don't have much interest in it. So my message to you again, please be very careful when you read papers about cross-domain recommendation. Most of it is based on, again, offline evaluations, not asking users. And in general, the main message is like anything that involves subjective perception of the user, please do studies with the users. And if there's no study with the user in a paper, be very cautious. Okay. So these were my four bugbears. So how things got so bad, right? Well, first of all, experiment. So a lot of people who do work in recommender system often come from other areas. So it's mostly statistics, machine learning, recommender systems. So they just borrow the evaluation or experimental paradigms that they used in the specific fields. But obviously, as I showed here before, a lot of problems recommender system are just unique to recommender systems. So maybe, the experiments that you run are not the most appropriate ones. precedents. Okay, so here, we as researchers are very guilty of it. Now, we want to have papers accepted at journals and conferences, and the easiest way to do it is to make sure that it follows the established paradigm of writing a paper and citing previous papers. So, we're very guilty of creating these problems ourselves. Culture. So as I mentioned before, a lot of researchers in recommender systems come from machine learning communities. They're not used to doing user studies, and sometimes they're not very interested in doing user studies. But recommender system is a field that is very much user-facing. So you should really, pay more attention to the user studies and what people think about your recommender system. Well, is anything being done to fix these problems? Well, very little. One of the problems is that for us in academia, it's very difficult to get funding for this. So, if you approach a funding agency and say like, hey, give me a couple of million so I can invalidate, the last 100 million over the 10 years that you poured into studying recommender systems, no one will give it to us. So, yeah, it is problematic. There is some research going on trying to make papers reproducible. So the top conferences like SIGIR and REXIS started having what's called reproducibility tracks that would try to reproduce the data and the model training. But again, they focus primarily on algorithms. There's no established track to actually establish user study focusing approaches. And even at REXIS, which is an HCI conference, or Human-Computer Interaction Conference, majority of papers still focus on algorithms, and these HCI-style papers, user-focused papers, are still a minority. What can be done? Okay, well, REXIS is still a young field, so hopefully we can get out of this machine learning-focused approaches and maybe establish our own paradigms of evaluation and conducting studies, which would be good. And we want to have more collaboration with the industry. And here, we want it to be adversarial, not in the sense that, you argue with us all the time. We want you to challenge us. When you read these papers, come back to us and challenge us of, what was written in the paper, what was correct or not. Please do it, because it will help us a lot. And in general, everyone should be much more skeptical when reading academic papers, both academics and the industry. So that's what I wanted to say. My last message, please be skeptical when you read academic papers. Thank you very much. Any questions?